Hello.
Hello.
Hello, sir.
Evening. How are you?
Evening. Thank you. How are you too?
Good, good. We're able to see.
Yes, we are.
Yes, sir.
Okay. So it's 17 hours and I think we can start.
Right away.
Yeah. Okay, so yesterday we were looking at linear functions. So today we proceed and look at a different topic. We look at quadratic functions. Okay. So if you remember, yesterday we said the linear function is a function of the form so f of x is equal to ax plus b, and that's a linear function. So today we go on and look at quadratic functions. So a quadratic function is simply a function of the form f of x being equal to, we have time ax squared plus bx plus c. So that is the form, the general form of a quadratic function. So like we did with linear functions, we looked at how to find the domain and range of a function or linear function. So even this one, we're going to look at how to find the domain and range of a linear function. So knowing that you guys first years and knowing that you've done sets, so I want to mention this. So the domain of a linear function, is simply all the real numbers, which is equal to, which you can write in this form. So OX, the domain we talk about the values of X. So it's OX such that X is a real number. So that is the domain of a linear function. This is just a recap. And then we also have that the range of this linear function here, we have, so the range of a linear function is also simply all the real numbers. And then we talk about this f of x, which we said you can let it equal y. So the range will also be OY in R. So this is, so a linear function is defined for all reals, and also the range we have that it's simply all the real numbers. So let's look at the quadratic function now, the domain and range of the quadratic function. So we have something like this here. So we have f of x being equal to ax squared plus bx plus c. So that is the general form of a quadratic function. So when you look at a quadratic function, you are going to see that this is defined for all x. So every number you put here, each and every number you put here, this function is going to be defined. So also the domain of this function, a quadratic function, this here will also be OX such that we have X being a real number. Or in set notation, you can say this is all the real numbers from minus infinity all the way to positive infinity. So that is the range of a quadratic function. So we are going to look at how to find. So sometimes it's not every time that the range of a quadratic function is going to be all the real numbers. So we are going to look at how to find the range of, the range of a quadratic function. Okay. Okay, so I want us to look at how to complete the square of a quadratic function. That is going to help us in finding the range of the function. And also we are going to talk about the minimum and maximum values of a quadratic function, which we talk about the turning point. So before we go there, we're going to talk about the graphs of a quadratic function. So let's give an example of a quadratic function here. So an example we can give is, say, f of x is equal to x squared minus 10x plus 22. So this is an example of a quadratic function, and its domain is simply this one here. Are we following?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so I love doing things in general, then we look at specific examples. So I want to show you how to complete the square of a quadratic function. So let's look at this. So we look at the general form of a quadratic function. So we are saying the general form of a quadratic function is f of x being equal to ax squared plus bx plus c. So I'm going to show you how you complete the square with this quadratic of this function here. So first things first, you have to make sure that the coefficient of x squared here is 1. So how do you achieve that? So okay, we say let's factor out a. So we say this is equal to b over a x plus c over a. Is that okay? So then from there, we find half the square of the coefficient of x here. So this is a. So we have x squared plus b over ax. Then we add this plus half the coefficient of x here is b over 2a. b over 2a squared. So you find half the square of the coefficient of x. Then you subtract it again to get b over 2a plus here. So we haven't, but we still, this is a complete square. You can factorize this one. So this will be equal to a. So when you factorize this one here, you are going to get x plus b over 2a squared. Then you have minus b over 2a squared, then plus c over a. A, and this is a x equal to a and is over e. So this a of equal to squared k squared. So that is for a squared that